Hello everybody, Mr. Gaza here, 186 earthquake waves, here we go. Excuse me, we are going to do the time math here. Okay, first thing you need to do, you probably need a separate sheet of paper. You will need a separate sheet of paper, you can't fit them all on here. You're going to need to rewrite these and do the math. Some you'll need to borrow for, and some you won't. Here we go, let's just not waste any time, jump in. What's the time difference between 11:40, 0 seconds, and this? So you want to rewrite it like this. 11:44:25. Highest number on top. Highest number on top. I can't say that enough. You need to do it. Okay, and then this is 0, 0. Okay. Anytime you borrow across the colon, be careful. But first you have to ask yourself, can I take 0 seconds away from 25? And you can, so you don't need to borrow, which makes things a little easier. 4 minus 0 is 4, and this is 0, 0, 0, and that's one way to do it. You could write it like that, or you can write it 4 minutes 25 seconds. Okay. Next up, I rewrote them to save a little bit of time. This one is again highest number on top, and then I ask just seconds here. Can I take 10 seconds away from 30 seconds? I can, and do the math. That's that. 3 minus 1 is 2. 8 minus that's 6, and 0, and 0, 0. And 6 minutes 20 seconds. 6 minutes 20 seconds. C. Let's do C. Write it out. That number on top. It's going to look like this. Can I take 30 from 30? Yes, I can. It's going to be 0. So I have 0 seconds. And then that's just going to be 1, and it's going to end up just being 1 minute and 0 seconds. And you could write it just like that, as I've said. Or you can write it like this, 1 minute, 0 seconds. Okay? Next up, this one here, write it, highest number on top. Then you're going to ask the question, can I take 40 away from 0? I can't. So I'm going to need to borrow. Now, I'm going to show you 2 ways to borrow. One is the way I've always shown it. The other one is a way that a student just showed me just yesterday. So let's do this one first, and you can choose which one you like. So I have to borrow here. Remember, this is minutes, so I'm going to borrow. 6 minutes becomes 5 minutes. Anytime you borrow across the colon, it should be a big warning sign. Warning, because you're not putting a 1 there. You're not borrowing 100 seconds. You're borrowing 60 seconds. Cross out whatever's here. Add 60 to it. That's 0, so that just becomes 60. And now you just do your regular math, as you've always done. 0 minus 0 is 0. 2. 5 minus 1 is 4. 4 minutes 20 seconds. 4 minutes 20 seconds. Now let me show you the other way. A student of mine just showed me yesterday. His name is Bray, and I thought it was great, and I'm going to show you his method. What he said was this. He said, if you need to borrow, when you're in a situation where you need to borrow, what you need to do is just figure out the difference here. What's the difference? And this is easy because it's 40 and 0, so 40 minus 0, and you make it a negative. He did it on the side like this. So you make that the seconds 40, and then what you do is you just carry 6 minus 1 is 5. Okay, so it's 5 minutes, and then take away 40 seconds from 5 minutes. Okay, and I guess people do that in your head. What's 40 seconds taken away from 5 minutes? And you get 4 minutes 20 seconds. Both of those work. You could choose which one you like better. But the answer to D is 4 minutes 20 seconds. Thank you, Bray, for that method, by the way. I think it's great. Here's one here. So I rewrote this one. What says E? So I put the higher number on top and the lower number on the bottom. And can I take 30 from 15? I can't. I need to borrow. So I'll do my traditional GASDA method. That'd be 47 minutes becomes 46 minutes. I have to cross this out, and I'm going to add my 60 seconds to the 15 seconds. You could do it on the side if you want. It doesn't matter how you do it. It's going to be 75 seconds. You write that in. 5 minus 0 is 5. 7 minus 3 is 4. And then 6 minus 3 is 3. The rest are zeros, and it ends up 3 minutes 45 seconds. 3 minutes 45 seconds. Let's do it the Bray way. Bray way. I think that's the nickname for it. So he suggests that, well, you can see you need to borrow here. Do this. What's the difference here? What's 30 minus 15 basically? Right? 15 seconds, no, negative 15 seconds, and then this is 7 minus 3 is 4. So you have 4 minutes, take away 15 seconds, 3 minutes, 45 seconds. God, I do love his method, and students seem to like it better as well, so great. This one here, what's this, F? Okay, I rewrote it, and I don't need to borrow. I can take 25 away from 40. And although I can't take 5 away from 0, so then this is just regular borrowing. The crazy borrowing to be concerned with is anytime you borrow across the colon. So I could just do what I've always done here. Make that a 3, make that 10. 10 minus 5 is 5, 3 minus 2 is 1. And then this is, I don't know how you normally would do it. Make that a 0, make that a 10, whatever it is. But it's going to be 3 minutes and 15 seconds. 3 minutes, 15 seconds. Okay, this video is going to be kind of long. I'm trying to go as quickly as possible, but I just want everyone needs to get this down. So here we go. Can I rewrote this higher number on top? Can I take 50 away from 10? I can't. I need to borrow. I borrow 1 minute from here. Becomes a 3. I add 60 seconds to that, so that becomes 70. And then I do this, and then I do this, and then 3 minus 2 is 1, and then 0, 0, 0. 1 minute, 20 seconds. I have the Bray way here for the same thing to show you again. What would his method says, so I need to borrow. What's the difference? What's 50 minus 10? Negative 40. And then this is 2 minutes, so what's 40? What's 40 seconds taken away from 2 minutes? You're going to get 1 minute, 20 seconds. And then this one, H is, I don't need to borrow here, so I go like this, 5 minus 3, and then 7, and it ends up being 7 minutes, 30 seconds. 7 minutes, 30 seconds. Okay. This here just helps you with the bottom of the reference table on page 11. This is basically 10 to the third is moving this 3 decimal places to the right, so that is going to be equal to this 2200. Again, moving 3 decimal places to the right, so that's 5,000. Okay. 3. How long does it take a P wave to travel 5,000 kilometers? You absolutely need a reference table here. You absolutely do. You gotta remember P wave and 5,000 kilometers. So it's page 11. P wave. So P wave is this line right here. Okay, and 5,000 kilometers. This is 5 times 10 to the 3. 5,000 is kilometers. So you go up here, right, where it intersects right there. You follow it over. 8 minutes, and count these out. If you need to count them out, figure it out. But that is 8 minutes and 20 seconds. 8 minutes, 20 seconds. 4. How long does it take a P wave to travel 4,000 kilometers? I'm back to this again. So, also P wave, always, common mistake is you use the S wave when S for P, or vice versa. And 4,000 up to, look, it's kind of like right on, I'm going to call it right on the 7. 7 minutes even. 7 minutes, 0 second. 5. An earthquake occurred 2,600 kilometers from seismic station D. How long after the earthquake did the P wave arrive at station D? So it's basically asking how long does it take a P wave to travel that far. 2,600, similar to what we just did. And again, this is P wave, so to keep those things in my head, P wave is here, 2,600 is here. Go up to there, and we're going to call that, it's 5 minutes even. 5 minutes, 0 seconds. How long after the earthquake did the S wave arrive at station D? S wave now, 2,600 kilometers. 2,600. So what that is, 26 is here. Is that up to the S wave? Oh, that's like, let's call that 9. This may be a little, maybe it's not even 9, 10. So let's call it 9 minutes. 9 minutes. 9 minutes, 0 seconds. What is the difference in arrival times of the P and the S wave? Well, if they both started at the same time, what they did at the earthquake, this took 5 minutes to get there. This took 9 minutes. The difference is basically the S wave got there 4 minutes after. That's like the difference in arrival time. So that math works out pretty easily. 6. A seismic station, Erie, Pennsylvania, received an S wave 11 minutes and 40 seconds after the earthquake occurred. How far away from Erie, Pennsylvania is the epicenter of this earthquake? This ends up being a math word problem. Kids have trouble with it at times, but basically what it's asking is, how far can an S wave travel? Does an S wave travel in 11 minutes and 40 seconds? So you have to go to this chart. Well, now you have to go here. 11 minutes 40 seconds is here. Okay, and you follow it over to the S wave to there, and then you follow that down to, where is that, 1140, and then you follow that down to here, and that is 3,600 kilometers. 3,600 kilometers. So it's really about understanding that chart and knowing how it works, and then like using it lots of different ways to find lots of different numbers. It's not really about memorizing just what I did there, because it is about understanding it. 7. A seismic station in New Orleans, Louisiana, recorded an earthquake. The P wave arrived at 3:43:15, and an S wave arrived at this time. What is the difference in arrival times? This is that time math, and to save some of our time, I did this one already. It doesn't involve borrowing. 6 minutes and 20 seconds is the time difference. Okay, I should have done it just like this. 6 minutes and 20 seconds. That's right here. 6 minutes 20 seconds. And then how far from New Orleans was the epicenter of this earthquake? Okay, so the difference is 6 minutes and 20 seconds. And this is what you need to do. We should have done this already in class. So the difference here between, basically, where is this 6 minutes and 20 seconds? And the best way to do it, with a nice sharpened pencil, you go like this, 0, and then mark 6 minutes and 20 seconds right there, and then see where where it touches both. Not there, really. It's probably going to be like right there. Is that right? 40? And is that 620? Yep, I said 620, right? Yeah, 620. Yeah, no, not there. That's probably the best answer. 40, follow it down right there. It's 4,600 kilometers. 4,600 kilometers. Okay. 8. The difference in arrival times of P and S waves is 3 minutes. How far from the epicenter is this seismic station? Seismic station is what records the earthquake waves. So now we're doing a similar thing, but with 3 minutes as our time difference. So we're going to use a different section of our scrap paper. We're going to mark 0. We're going to mark 3 minutes. And then we're going to see where it touches both, keeping our paper straight up and down. Ooh, that's probably the best right there. Look at that. Right there. So that is right there, and that is 1,800 kilometers. 1,800 kilometers. And 9. Now it's saying the difference in arrival times is 8 minutes and 20 seconds. How far from the epicenter is this seismic station? 8:20. New section, a clean section of my scrap paper here. Sorry this video is going long. It's just, I knew it would. But this is, you get this down, you're in good shape. What was it? 8:20, I think. 8:20 right there. 8:20. Let me just check again. Yes, it gives you 8:20. I'm going to be all the way over here on my chart. 8:20. 8:20. Is it there? It's probably right about there. Okay. Right about there. I follow it down to here, and it should be 6,800 kilometers. 6,800 kilometers. Now, the back. If you're at home right now, you can't do the back because you probably don't have a drawing compass. So I'm not really going to go over that now. We can do that other ways. And if you're in class, you can just ask me. But so that right there is 186. Thanks for watching, everyone. All of us here at Gazdonian Productions. Thank you.